talking about details, I I want to talk about the legend of a king named Midas who had one wish, and when the gods granted him the wish, he wished that everything he touched would turn to gold. Midas was delighted, and trees, rocks, buildings would start to turn all gold. But soon he found in horror that everything he touches turns to gold. So the food he wants to eat is also turning into gold. And when he hugged his daughter to soothe his pain, he realized his mistake. Okay. So the richest man in existence was starving, heartbroken, and alone. So similarly, humanity got a similar wish granted when we learned how to turn this black, stinky substance into magic. This magic is plastic. So plastic is cheap, sterile, and convenient to use, and it changed our lives. But this wonder of technology got a little out of hand. Plastic has saturated our environment. It has invaded the animals we eat, and now it's finding the way to our food chain, to our and food chain, and thus our bodies. So, what is plastic? For most of our history, humans use stuff in the nature to build the things we needed. But the invention of plastic roughly 100 years ago completely changed our world. Our world. Plastic is made from polymers. So polymers are long chains of repeating chains of molecule groups. So there are plenty of polymers in the nature. The walls of cells, silk, hair, DNA, and etc. But it's also possible to create these polymers. And by breaking down crude oil into its components and rearranging them, we found a way to create synthetic polymers. So these polymers have extraordinary traits. They are lightweight, durable, and can be molded into almost anything, any shape. So they are not time-consuming, and they do not require manual work, and they are easily mass-produced. And their raw materials are easily available in the nature. Um, So bakelite is used for mechanical parts, PVC is used for plumbing, electric gears and cases, acrylic is a shatter resistant for alternative to glass, and nylon for stockings and war equipment. So everything in our lives has plastic. But sometime after this revolution, this plastic ceased to be a revolutionary material. Instead, it became a trash. So uh, so one bad thing about this plastic uh, is that it is not biodegradable, and since it's very durable, it can take hundreds of years for it to break down. Uh, so somehow we decided to use this non-biodegradable material for in our packaging, and about 40% of plastics is used in packaging. Uh, and what happens to these plastics after we use it? 9% is recycled, 12% is burned, and but 79% is left sticking around. And most of it, some of it ends up in the oceans. Uh, so I'm not gonna start the video. So and uh, so this garbage started gathering in our oceans, and because of these big ocean currents called gyres, and there are like five main gyres in the oceans, and the most dangerous one is the North Pacific one. It's the biggest one actually. So um, so these are some of the facts. 60 to 80% of all marine debris is plastic. Gyres, the ocean currents, gather plastic in the ocean into massive floating garbage patches, and up to 100,000 animals die from eating plastic or being entangled in the plastic. So, and also some plastics release toxins when they degrade. But there is one problem with plastic. It's that uh, plastic is also important for us because some of the alternatives for plastic, for example, cotton or uh, wood, can have much higher environmental impact than plastic. For example, in carbon dioxide emissions. So, for example, Danish government research showed that uh, that you need to use your cotton bag 7,100 times before it would have a lower impact on the environment than the plastic bag. So, so this is a problem of trade-offs. Mm. So also, plastic helps us not to keep the food fresh. Uh, that's why it's important. Otherwise, the food ends up in the landfills and begins to rot, and this leads to generation of methane. So our motivation in this project is that uh, the plastic is lethal, is a deadly threat to fish, seabirds, marine reptiles, and mammals that live in the oceans, as well as humans, since plastic enters our food chain. Uh, so and so the thing is that there are already processes for turning plastic into something useful like fuel, and this process is called pyrolysis. But the thing is, uh, and also the much focus is on creating alternatives to plastics that are biodegradable, and I think we have success in that as well. But the remaining problem is collecting this existing plastics from the oceans. That is the main issue. So there are some ongoing projects. Uh, like two popular ones are Mr. Trashville and the Ocean Cleanup. So Mr. Trashville is created in Maryland, Baltimore. So it is a moored vessel that removes trash from the mouth of the Jones Fall River at Baltimore's Inner Harbor. Rubbish from the streets of Baltimore is flushed into storm drains that empty into the Jones Falls River. The floating rubbish is then carried by the river to its outlet into the Inner Harbor, where it is captured by Mr. Trashville. Mr. Trashville is powered by the current, and solar cells are used as a backup system when the current is sluggish. This energy, this water wheels and solar system power the conveyor belt, and Mr. Trashville removes floating debris using rotating forks that dip into and out of the water, and which then place the trash onto a conveyor belt, which moves it into dumpster. So this is Mr. Trashville. So there are some major drawbacks for this system. First, it's not available in the oceans, and it's very small scale, and it is fixed. It is a fixed structure at the mouth, at the outlet of the river. So you have we also have to consider the shape of the harbor for the design, like consideration of the shape, and also uh, it needs constant supervision in operation and maintenance. The second very famous project is the ocean cleanup. So in this system, uh, there is a video.
$1.8 trillion pieces of plastic float at the surface of the Great Pacific Garbage Patch. Here, the ocean cleanup is deploying the world's first technological solution to this growing problem. The principle behind it is simple. Create a coastline where there are none. Concentrate the plastic and take it out. The system consists of a 600-meter long floater and a 3-meter deep skirt attached below. The floater provides buoyancy to the system and prevents plastic from flowing over it. while the skirt prevents smaller particles from escaping underneath. As the impenetrable skirt creates a downward flow, marine life can safely pass beneath it. Here is how the system catches plastic. The system takes advantage of three natural oceanic forces: winds, waves, and currents. Both the plastic and system are being carried by the current. However, wind and waves propel the system only, as the floater partly sticks above the surface, while plastic is primarily just beneath it. The system thus moves faster than the plastic, allowing the plastic to be captured. The skirt extends deeper in the middle of the system than on the outer edges. As the current applies pressure on the skirt, the system naturally adopts a U shape, which enables it to concentrate plastic in its center, like a funnel. The drag generated by the skirt also acts as a stabilizing force, allowing the system to reorient itself when the wind changes direction. And because the system, like the plastic, is free floating, it automatically drifts to the areas with the highest plastic concentration. Fitted with solar powered lights, anti collision systems, cameras, sensors, and satellite antennas, the system actively communicates its position at all times and continuously gathers performance data. Periodically, a support vessel comes by to take out the concentrated plastic, like a garbage truck of the ocean. The plastic is then transported to land, recycled, and made into durable products. This is the first of a fleet of 60 systems. Once deployed, the fleet is expected to clean up 50% of the Great Pacific Garbage Patch every month.
So so it creates a floater, 600-meter floater, and it has a mm, deeper part, 3 meters deep. It's a tapered skirt. So the floater is for buoyancy to keep the structure afloat, and the skirt is to stop the debris from escaping. So due to the difference in the velocity between the structure and the trash, uh, the trash is enclosed in a smaller and smaller area, and then the ships come and collect the garbage. So what's the problem? Actually, honestly, I couldn't find many problems with this project, and this project has been ongoing for quite some time. And they, at first, they were not that successful, but we could find some of the issues associated with this project. So first, the wind against the system make ends of the floating pipe oscillate back, and that motion slows down the system. So the expected amount of trash may not be collected. And also it can handle small pieces of plastic in the seas. And its installation, as you saw, the length of the structure is very long. So installation cost is high, and I think yeah, it's a bit hard to maintain and operate this structure. So our approach, we were inspired by the nature. We looked at some of the phenomena happening in the nature. So here's one of the things that inspired us is the respiration and feeding of whales. So as you know, whales are mammals, so they need to go to the surface of the ocean to breathe. So I mean, probably you've seen from Discovery Channel or National Geographic documentaries that they have a hole called blowhole on top of their heads, and they sometimes when a whale breathes air out of its blowhole, it shows up as a spray um, uh, or mist called a spout. So blowholes are surrounded by muscles that keep hole closed when the whale or dolphin is underwater, or open it when the animal is at the surface and it needs to breathe. So the respiration system shows that whales accept selectively, like pick everything like oxygen, and then remove the remaining oxygen and the remaining substances via the hole. So, and the second is the feeding of whales. Uh, uh, they open their, as you can see, they open their mouths and they accept large amounts of water, and along with the water, they they accept the krill, the other fish, planktons, and they feed this way. But as you can see, they also accept a lot of water with that. So the whales have this structure called baleen plates, which uh, they accept mouthfuls of water and food together, and then they push the water back out using their baleen plates as a strainer, keeping the food in their mouths but water out. So baleen is a filter feeder system inside the mouths of baleen whales. The baleen system works by a whale operating its mouth underwater and taking in water. The whale then pushes the water out, and animals such as krill are filtered by the baleen and remain as food source for the whale. Baleen is similar to bristles and consists of keratin, and the same substance found in human fingernails and hair. So we thought of the making a large hollow structure which is submerged in water, and we don't have particular design, but the analogy would be similar. That the structure accepts large chunks of water, but just like dolphins and whales that separate oxygen and water, or food and water, our system hopefully can separate water and plastics from each other. And uh, we're planning to make a floating structure just above the our filtering structure, just like analogy would be an iceberg. So there is a large underwater part and a small upper floating structure. So, and in order to push the collected garbage, we found some projects using vortex, induced vortex. So inducing vortex could help push the garbage up to the floating structure, and then upon collecting the garbage on that structure, helicopter or ships can come and unload the garbage from the structure. So, so this is mainly inspired by the systems of whales, marine mammals, namely dolphins and whales. That's it. Thank you. Yes. Ah, ah, just a moment. I need to find that. Uh, so more than 6.3 billion metric tons of plastics have become waste since 1907. Since its invention, we have produced about 8.3 billion metric tons of plastics. 9% is recycled, 12% is burned, and 79% of it is sticking around still. Is that what? Yeah, like some part of it is in the landfills on the land, but that's not that big of a problem than the part that is in the ocean. Some part of the 79% is in the ocean. Other questions? Sorry? Ah, yeah. It's very long. I actually skipped a lot of. Ah. Right now? Because it's like separate document. It's very long. Ah, when I submit? Ah, yeah, sure. Yeah, because it was long, I skipped a lot of parts, and I still was. Yeah. Yeah. Yes. Other questions? Basically, I I think you have to bring that. Like it's not like it doesn't have like propelling much of a propelling system to go there. You have to put it there. Yes.
So your system doesn't actually suction the flow?
Pardon?
Your system does not actively suction the flow if it's
No, I haven't thought specifically about that, but what we imagine is controlling the opening surface to the flow, putting the controlling the structures so that it is always against the flow, and the water with the plastics goes inside by itself. There's no suction system, but we thought of about the pumping the garbage up. We thought of vortex, but that's like right now it's a bit vague, not like particularly specified. Uh, no.